This next video brought to you by Armless Lego Skeleton. So we kind of already did this in the previous video. Um, we're just going to solve these graphically. Now I'm going to ignore this calculator, graphing calculator, and say Desmos. And to get the approximate solutions, and then ask ourselves, could we get either of these solutions analytically? So what I will do in this case, I showed the intersect method in the last one. I'm going to now show the intercepts method. So I'm going to get the equation equal to 0. We're just going to graph this left side and see where does it hit the x-axis. So here goes this first one. Let me get a new, oh, that's not the button. Let me get a new graph. And we did e to the, now notice I have to put in parentheses to make sure I get 7.2 times x, otherwise it pops the x down. And then minus 14.009. So since we're looking for where does it hit 0, we just find where on the x-axis is it, and then we're going to draw ourselves kind of a nice, neat little graph of that. And by neat, I mean just a whatever graph. If I zoom out a little, you can get a fuller picture of it. Maybe we want to show the y-intercept too on our graph to be like nice and accurate, whatever. And then that solution is approximately 0.367. This is what I put on my paper. If I was grading your exam, this would get full credit. All right, we'll do the same thing on the next one. I'm going to subtract the 3 from both sides, so I'll have x e to the 3x minus 4 equals 0. And let's smash that into Desmos. So it was x e to the, again, we need parentheses around that 3x, and minus 4. And all we have to do is find that x-intercept. There is only 1.621. Let's draw that graph. You can see if we zoom in a little bit here, we can see kind of the effect that x is having. It creates this, what do we call that? I'm forgetting what we call that at the moment. You all know, remind me, what do we call it? That's a minimum. There it is. So here's my graph. It's terrible, but it'll do. Also notice the horizontal asymptote appears to be -4. At any rate, the solution we're interested in here is 0.621. So this is a terrible graph. I might be tempted to not give you full credit to that because it's so bad. Plus, I didn't give the y-intercept, but whatever. It gets the point. Our solution here is approximately 0.621. Our solution over here was approximately 0.367. So could we do these analytically? Sure, this first one definitely, right? Here I have a base equal to a base. Take natural log of both sides, and you get this. Divide both sides by 7.2, and here's the exact answer that, from what we already found from the graph, is approximately equal to 0.367. All right, let's do the same thing on the other problem. Let's try to get it as a base equal to a base. So here I'll add 1 to the other side. I'll have x e to the 3x equals 4. And then, boy, we're in trouble, right? Because we have an x in the base, so we have a variable in the base as well as in the exponent. If I chose to take natural log of both sides, this is fine, right? Because this is still just a number. But over here, like, the best we could do is write this as a sum of these two things. And then we could get that exponent out of the, or that x out of the exponent. So we have natural log of x, absolutely nothing we can do with that, plus 3x times natural log of e equals natural log of 4. And now we know that this is equal to 1, so we can rewrite this thing as 3x plus natural log of x equals natural log of 4. But I don't know of a way currently for us to combine these. So we're kind of stuck. Our best option here is this.